Okay, so in the last classes we have discussed about the different type of models regarding with the ionic reactions, and we try to discuss about how the different type of ionic reactions were occurring and what is the effect on the dielectric constant or on the rate of the reactions, and also the charge on the rate of the ionic reactions. Now the thing is that how these ionic reactions are occurring based upon the double sphere model and single sphere model we have tried to understood. But the thing is that what are the different consequences of these spheroid models which we have discussed in the last classes that we will discuss today. So we will write consequences of models of ionic reactions. So the first let us say, based upon the ionic models, let us say two ions are approaching closer to each other from an infinite distance, but each ion are having positive charge on it. This is also having a positive charge. A ion is having a positive charge. B ion is also having a positive charge. So what will happen? As these ions, obviously it will present in a solution phase. That means these ions will be associated with solvent molecules. So here the charge is unit 1. The unit is 1. Therefore let us say this will be associated with some solvent molecules, where the opposite dipole of the solvent molecule is directed with the ion. That means the solvent will be associated with the ion through ion dipole interaction. So we can consider as number of solvent molecule associated with this A ion is equivalent with the number of solvent molecule associated with the B ion, because the number of charges is same and also nature of the charge is also same. So if I am saying 1 2 3 4 5 6 solvent molecule is associated with this A ion, then we can write the similar structure would be there, and here also the same number of solvent molecules will be associated with the ion. Okay, so now according to sphere models, what will happen when they will come closer to each other? They will form an intact structure, that is we were calling the activated complex. So a activated complex will be formed where the two ions will remain intact with each other. This is the activated complex. And what will happen? So when obviously, as like the ions which are present in the reaction, which are acting as a reactant ionic species, they are solvated in nature. In the similar nature, the ions which are now forming a activated complex will now also be forming a solvated atmosphere. That means this activated complex will also be surrounded by the solvent molecules by ion dipole interaction also. But the thing is that as the ions are having one unit of positive charge, but now when this will form an activated complex, then as a whole the activated complex, this activated complex is having two unit of positive charge in one from each from one ion. That means two unit of positive charge, and you already know the amount of solvation. The amount of solvation depends upon the charge density on the ion. If the greater the charge on the ion will be, greater would be the solvation. So here, as the number of unit of charges increases in the activated complex, therefore the solvent molecules will be more surrounded near the activated complex. So what would be the structure? This will be densely populated. The solvent molecules near the activated complex will be densely populated. What do you mean by densely populated? That means as compared to the initially present ions, where the solvent molecules, whatever the number would be, now when they will be forming the activated complex, as the number of unit charges increases, therefore the number of solvent molecules surrounding the activated complex will also increase due to the larger amount of magnitude of ion dipole interaction. So what does this signify? That means in the reactant state, large number of solvent molecules will also be there which are not associated with the ions. Here large number of solvent molecules are not associated with reactant ionic species. But here, as the unit charge increases, the large number of solvent molecules will get associated with the activated complex. So large number of solvent molecules get associated with activated complex. As a result, of which what will happen? The simple result is that you can say the very large number of solvent molecules should be there which are moving very freely. Solvent molecules are free. And this I am talking about in comparative study. But here the solvent molecules, large number of solvent molecules are remain intact with the activated complex. Therefore, very less number of solvent molecules will remain free. And you know that free, what do you mean by free, which I am talking about? That means the motion is free. That means the solvent molecules can move in any possible direction, in any random direction. Why? Because they are not associated with any type of ions. Their motion is not restricted. During their motion, no one is creating obstacle. So that, in that sense, I am talking about free. And if large number of solvent molecules are free, they are able to move in any possible direction. Their motion is random. That means you would say the randomness of the system is higher, or the disorderness of the system is very higher. And the measure of randomness or disorderness is nothing but entropy. That means entropy in this case will be very much higher. But when I talk about the activated state in the activated complex, as very large number of solvent molecules get associated with the activated complex, therefore very less number of solvent molecules will become free, very less solvent molecules are able to move freely, therefore the randomness of total system actually decreases. That is, your disorderness of total system decreases. That is, your entropy decreases. Entropy decreases. So if you calculate the entropy of activation, what would happen? This is nothing but the entropy of activated complex minus entropy of reactant species. So which would have a larger value? The entropy of reactant would have a larger value as the solvent molecules are free, they are able to move freely, they are more random in nature, therefore this would have a larger value and this would have a smaller value, therefore there is a negative value if you calculate the change in entropy of activation. Therefore, on moving from reactant ionic species to the activated complex, the entropy of the system decreases, and due to the restriction in the motion of the solvent molecules. And why this restriction? As they are remain intact with the activated complex due to the increase in the charges, overall charges. And this process where the random motion of the solvent molecule got restricted due to the increase in the charge on the species activated complex, this process is generally called as electrorestriction. What it is called as? Electrorestriction. So what we can write? The solvent molecules, in the neighborhood of an ion are acted upon by strong electrostatic forces which restrict their freedom of motion. Whose freedom of motion? Solvent molecules, obviously. Freedom of motion. This effect is known as electrorestriction. That means there is a loss of entropy. And this loss of entropy is greater if the charge on the activated complex will be larger. There will be more restriction. There will be more associated solvent molecules. Okay, but you can note down something. What you can note down, actually here the ions were free, but when they form activated complex, they remain intact. That means the ions initially, when they were not forming activated complex, they were more free in nature. But when they remain intact, actually the freeness or the randomness of the ions is decreases in intact structure or the activated complex. Therefore, there is some loss of entropy due to the formation of intact structure or activated complex. But this sorry no, I'm right. Loss of entropy, yes, there is loss of entropy. But the thing is that this loss of entropy due to the ions is very, very small as compared to what we have discussed regarding the solvent molecules. This should be very small as compared to solvent molecules. Okay, yes, in case of ions forming the activated complex, they are more free when they are present in free state, when they are not associated with each other. But when they will be associated with each other, obviously the freeness will decrease, the randomness will decrease, the entropy will decrease. But this loss in entropy due to the ionic species is very less as compared to the solvent molecules associated with that. Okay, so during the discussion of the entropy of activation for the ionic reaction, there are actually two types of entropy. One, it is due to the entropy due to the solvation, what is happening to the solvated atmosphere, whether the solvated atmosphere is increases or decreases, number of solvent associated increases or decreases. In that point of view, we can define the entropy. Similarly, we can define the entropy in terms of ionic species. So when they are free, when they are not associated, what is the value of entropy? When they are associated with each other, that is forming activated complex, what would be happening with the entropy? So there are two contribution towards the total entropy of activation. One is regarding the number of solvent molecules, and another one is regarding to the number of ions. Okay, so we will now take up another case. This is the case number 1, where we have discussed that whenever two ions approach each other and when they will form the activated complex, as a whole the charge on the activated complex actually increases. But we will take now second case, and second case you will see that as compared to the ionic species, the charge on the activated complex rather on increase, it will decrease. Okay, what is the scenario? So let us take a simple case where a positive ion is approaching towards a negatively charged ion, or negative charge ion and positive charge ion, they are simultaneously approaching each other. This should have a 1 unit of positive charge, and this is having also a 1 unit of positive charge also. Let us just differentiate, it would be better. Okay, so two ions of opposite charges are approaching towards each other. Okay, and after approaching, what will happen? After approaching each other, what will happen? They will form an activated complex, and if and you already know what is the charge on the activated complex should be. This is the sum total or algebraic sum of the charges due to the each ion. So what is the total charge on the activated complex? Plus 1 minus 1, that is equal to 0 charge. 0 charge. 0 charge appear on the activated complex. But when you will consider the isolated ions, when they are not associated with each other, there is unit positive charge on a cation and unit negative charge on anion. That means if I try to, obviously these are the ionic reaction and they will be present in the solvent medium, and they will be associated with the solvent medium, solvent molecules also. So if I draw some like this, let us say this is associated with 6 solvent molecules, and this is associated with also, as the unit is same, this will also be associated with the same number of solvent molecules, but here this will, here the positive dipole will be directed. Here the positive dipole will be directed. But when activated complex will be forming as a whole, what will actually happen? As the number of charges is decreasing on the activated complex, therefore the number of solvent molecules associated with the activated complex is also decreases. Okay, decreases we have to see. Okay, so what will happen? What is shown here? We are showing that here more solvent molecules associated with the isolated ions. Here less solvent molecules are associated with the activated complex. As a result, here large number of solvent molecules, less number of solvent molecules will remain free. Here large number of solvent molecules will remain free. So here as a result the randomness would be lesser here, but here the randomness would be larger here. As more solvent molecules are remaining free, they are able to move in any random direction, therefore the randomness would increase. So what will happen to the entropy? As entropy is the measure of randomness is lesser, that means entropy is also be lesser, and here the entropy is also be larger. So if you talk about the entropy of activation, which is the difference of entropy of activated complex from entropy of reactants, that means you can know in the reactant side the entropy is lesser and the activated complex side the entropy is larger. That is, it would give a increase in entropy of activation. You are getting a positive value. Therefore, you can say on moving from reactant side to product side or the activated complex side, the solvent molecules are facing lesser restriction due to the neutralization of charges appearing on the respective ions. Therefore, you can see that there is decrease in electrorestriction. Okay, so you can write down कि when the charge